Hi, kids. All right. Hi, kids. I'm going to do a little short instructional video on first law of thermodynamics. If you look on your equation sheet, you will see actually two equations right about now, which is work equals negative P delta V, which we'll talk about, and delta U equals Q plus W. The delta U equals Q plus W, that's really the first law of thermodynamics. First law of thermodynamics is really just conservation of energy. You know, kind of all year long in this class, we've talked about conservation of energy, conservation of energy. This is another example of conservation of energy. So the delta U, Q, W, a lot of times, you know, I'll give you a problem like this, and sometimes you have to be able to work out the math, and the math is not hard. It's like, hey, if this is 30 and this or 300 and this is 600, then delta U is 900, that type of thing. But a lot of times you're gonna have to, the tough part is figuring out like the signs of everything. So let's talk about this. So if we do this one, okay, isothermal. Iso, same, thermal, temperature. So this is something where you have the same temperature. You go back to our PV equals nRT. If that's constant, if this goes up, this has to go down, that type of thing. Or in this case, it'd be the vice versa. If my pressure is decreasing, then my volume must increase. They're inversely related, so like this. If you're to do this, okay, well, wait a second here. Isothermal, same temperature. So here's what this means. This is based on temperature. Remember this equation, U equals 3/2 nKT. Okay, the internal energy of your gas strictly depends on the temperature and some other constants and the number of molecules. But if my temperature is staying the same, then that means that has no change. Wow! But then if you guys take a look here, all right, my volume is going up. So if my volume is going up, that means the gas is pushing the piston. Well, if the gas is pushing the piston, the gas is doing work. If the gas is doing work, the gas is losing energy, which is why that is negative. You can also get it from this equation, which is on your equation sheet, but really I would like you guys to be able to think about it, because a lot of times you'll see the wording things like going like this, the gas does the work. Like, you have to understand that. And then if the gas does the work, what does that mean? That means the gas it's negative work, it's losing energy, okay? Well, if you look, if this is 0 and that's negative, that means Q has to be positive. So that means for this process to happen, you have to add energy to the gas. How do you do that? Oh, with a flame or something like that. But there you go. Okay, so that's the thought process. If I go through kind of the thought process for each of these, if you have isobaric, iso, same, baric, talking about like barometers, pressure, so that means the same pressure. If I'm going this way, if you guys think about your PV equals nRT, so this is equal, this is going down, therefore my temperature has to go down. If my temperature goes down, my delta U has to be negative. All right, so if I go from here to here, that means something is compressing the piston, so the gas has work done to it, okay? So the gas has work done to it, which means this is positive. You could also do it with the formula, but again, make sure you understand the words, because you're going to see the words a lot of times on the test. So if this is negative and that's positive, well, this has to be a bigger negative number. So that means I am taking heat out of my gas. Well, what does that mean? What is heat? It's just energy. I'm taking energy out of the gas. Is everybody with me there okay? So that would be isobaric. If you have this one, isometric, same, dealing with metrics. Oh, that would be the volume, same volume. So in this case, if it's going this way, so go back to your PV equals nRT if you think. All right, so this is the same. My pressure is going up. Therefore, my temperature has to go up. So that means my delta U is positive. Well, wait a second here. I have no work done. Why? Well, there's no change in volume. Remember, work is force times distance. You got to have a distance. If there's no distance, there's no work. So this would be 0. Well, if that's 0 and that's positive, that means I would have to add heat to my system. The other way you can think about this, guys, just as a reminder as far as finding work, remember the work is the area. The work is the area. You guys with me there? Okay. Let's see, what else? Oh, depending on how far you are in the unit, there is one other one, which is adiabatic. Okay. If this was isothermal, adiabatic is steeper. Okay. What does adiabatic mean? Adiabatic means there's no heat exchange between the gas and the surrounding system. There's whatever is surrounding my gas. So in that case, if this is my adiabatic one, this would be 0. There's no heat exchange. If I'm going this way, do I have to go that way? No. But if I am going this way, my volume is going up. So the gas is doing the work. So the gas is losing energy. So this is negative, which means, in this case, that would have to be negative. So anyway, that's kind of like the instructional piece of it, the conceptual piece of it. Make sure you guys practice putting in actual numbers because you're going to be responsible for that too. Bye, kids.